Welcome to lesson 4, part A. We are going to introduce the first component of the sensitivity analysis tier. This first component deals with sensitivity to sample variability, and it's able to reckon up a more reliable estimate of the performance lower confidence limit. Let's dig into sampling variability first. According to the MASASP methodology, performance estimates refer just to the out-of samples, then they are already reliable in that they prevent overfitting and they are fully compliant with the honest assessment provisions. Besides, statistical tests are conducted and they relate to the out-of sample too. The performance reported in the outcome discussed in Lesson 2 and Lesson 3 are reliable. We look, though, for an even more reliable estimate, which resorts to the sensitivity analysis in order to figure out the extent to which performance might downgrade if the future time series, let me say the future test samples, are different from the test samples accounted for in the previous assessment years. Well, in order to quantify this downgrade, we need to simulate this different time series, these different test samples. This simulation consists in generating several new test sets obtained by picking traits from the original test set at random. Let's generate a first simulated test set, picking just the traits colored green. The ones in blue are discarded. Then we generate a second test set in the same way. And so on. And so on until we have quite a number of these sets. For math lovers, let's get a bit into the technicalities of this trait picking at random. What we do here is called unrestricted random sampling. That means that we can pick up the same trait twice or even more times to put it into the same output set. That provides a definite worst-case approach, because extreme big loss traits can wind up into the same test set twice or 3 times or more. We iterate this process of generating new test sets until we have at least 1,000 samples. This analysis is called bootstrapping. The boot component is named after that. Well, now we can reckon up the performance estimate for each sample and plot the probability distribution of these estimates so that we can compute a lower confidence limit. That is indicated as H5 which stands for 5th percentile of said distribution. The bootstrapping component outcome shows this confidence limit along with the previous out-of-sample estimate, which is called point estimate. The latter in this chart is plotting as a green straight line, but it would also be recognizable as the vertical axis of symmetry of the plotted distribution, as this distribution is centered around the point estimate. That is the mean value of the distribution. The possible performance downgrade then is given by the difference between the point estimate, the green line, and the lower confidence limit, the orange line. Here it comes the real-life example. Let's see the conservative long strategy on gold. The performance metric in question is the expectancy, measured in basis points. We see here that the point estimate is nearly 70 basis points. That value is recognizable as the center, the mean value of the plotted distribution. The report header indicates the lower confidence limit, which happens to be nearly 29 basis points. If we trace a vertical line at this value, we can graphically appreciate the possible downgrade. Thanks for watching. In the next video, Lesson 4, Part B, we are going to introduce the transaction cost issue.